Hi, we're going to do section 8.3 practice problems for confidence intervals for means. But first, let's go back to 8.2 where I messed up on one of the practice problems. You did this one in class. Well, if you're B.A, I haven't seen you, so we didn't do it in class yet. But if you flip over to number 5, so all you 8A people out here in my YouTube video, it's incorrect. Random sampling errors is sampling error, which means what? It means that all your sample results are different.
Come to the attendance office. Thank you.
All sample results will be different. Some will probably be the same, but for the most part, they're going to be different. So that's called sampling error. So random sampling error is included in your margin of error. However, errors due to undercoverage and non-response, no. That's just you didn't pick the right sample, you didn't do it correctly, bad sampling. Errors due to using sample standard deviations as estimates for your population, yes. So the answer should have been 1 and 3, and I had only said 3. Now let's talk about child development and potty training ages for babies in months. First off, I want you to know that there's data here, they're numbers. So it's going to be a sample mean problem, not proportion. And since they're giving you numbers, you're going to need to enter these values into a list in your calculator because you're going to make a graph later on in your conditions. So that's the first thing when you look at this problem, you should say, hey, I have numbers and I'm going to put them in my calculator and make a list and make a graph. So we have 10 years ago, the average age in months that babies officially became potty trained was 26 months. The scientists are concerned that babies have become lazy over the 10 years and are taking longer to become potty trained. Should the scientists be concerned? Well, probably not because I made this problem up. State what you want to know. We want to create a 95% confidence interval to estimate the average age babies are potty trained. Plan your conditions. First check, did you have a random sample? Yes, we had a random sample of 15 babies, so we just need to reiterate that. We have a random sample of 15 babies, which means that our sample is small enough, just like it was before. The next one, we're no longer looking for successes and failures, we're concerned about our sample size, and if it's large enough. N is not bigger than 30, so our sample size, N, equals 15. If it was 30 or larger, we'd be good to go. We would just say, hey, our sample size is large enough, it's at least 30, and we could continue. However, it's only 15. So this is where you make a graph of your data. You want to be able to say that the ages are approximately symmetric and unimodal and without outliers. So you go to your calculator, turn it on, oops, don't look at that yet, hit stat, enter, and I put all the ages in L5. There are 15 of them, so when you put them in, double check to make sure you have enough. And then hit second, y equals. And pick the graph you want to use. You could make a histogram, and your X list should be where you put your data, L5. And then zoom 9, and you can see that it looks approximately symmetric. If you're not happy with the window, you can always change it. Make your X-Men, I don't know, let's go down to 18 X max, it was counting almost by 4s, so let's count by 4s. Let's change that 18 to 20 because 4 doesn't go into 18. And it was going up to 43, so let's make it go up to 44. Y max, I don't know, we could change that to 10 just in case it's not large enough. Make that 0. Now hit graph. Whenever you play with your window, you should hit graph. Hey, it's not unimodal, but it is approximately symmetric, roughly symmetric. It's good enough. You can hit trace and see the length of your bars and how high they are, so you could quickly copy it down on your paper. However, I know some of you don't like histograms. I don't know why. So you can hit second y equals, go back in, and change it to the box plot with the outliers. Zoom 9, and there it is. And once again, you can hit trace to help you quickly copy it down. We'll stick with the box plot since that's what most of 8A wanted. So I have my box plot here. I'm going to just draw my little line, and then I have my dot. That's 21. And then I have a bar. Here's my box. Pretty symmetric looking. And there's another little outlier. And when I hit trace and I arrow back and forth, I can see the values that this is 23 and 29, 31, 33, 39, and 40. And I could title it as Ages of Potty Training. Now I need to say something about it, and I'm going to say it's approximately symmetric. Ages are roughly symmetric. I can't say it's unimodal because I'm not looking at a histogram. So don't be silly and say things that don't apply to a box plot. You can say that they're roughly symmetric and with 2 outliers, 21 and 40. Now this is where you got to be smarter than the problem. Technically this condition wasn't met, so I'm going to look down at the rest of the problem. Is there anything telling me, hey, you shouldn't have done that, why aren't your results reliable, we're going to add more data? Nope, none of that. So to make myself feel better, remember I made this problem up so it's not perfect. The 2 outliers, I'm going to say proceed with caution. You don't have to say this part, but I'm still going to apply the normal model. And we're going to do a T interval. Oops, white out, love white out. For one sample mean. So this is where we go to the calculator, and I'm going to hit stat, go over to tests, and now I'm looking for a T interval. It doesn't say one sample T interval, it will just say T interval. It's number 8. Select that one. Once in a while the problem will give you actual statistics. In the problem you just plug them in. This one gave us a list of numbers, so that's considered data. I highlight data. I need to tell it what list I put my data in. I put mine in L5. If yours is in L1, keep it there. Frequency should always be 1, and we want what level confidence? 0.95. So I'm going to calculate. Here's my answer. So I'm going to copy down that information onto my paper. Now remember you named it, so you don't have to put the formula. The formula would be x bar plus or minus t star times your standard deviation over the square root of n. However, like I said, you don't need to put that. But you do need to put all that information down. X bar from the calculator is 30.8. The standard deviation, that S sub x, is 5.116. My sample size is 15. And my interval is 27.967 to 33.633. Now, that's my do. I just need to do my conclusion. So to conclude, I'm going to say that we are 95% confident that the true average age babies are potty trained falls between approximately 28 and 33.6 months. To explain what it means in context, this is where a lot of people are trying to get the bonus on the quiz and they weren't able to do it. I'm going to have to cut us off though, because that was the end of nest. All right. How do I stop? Do I just hit